Hello, my name is Matthew Martel, and I'm an undergraduate exercise science student here at UMass Lowell. Today, I'm going to tell you about my literature review titled The Effects of Exercise on Satellite Cell Regulation in Aging Muscles. The overarching condition that I focused on is sarcopenia, which is the atrophy and weakness of muscle in aging. Recently, it has been described that age-associated impairments in our satellite cells, stem cells responsible for muscle fiber generation and repair, play a role in the development of sarcopenia through permanent inactivation or senescence of the satellite cell. The effects of sarcopenia become especially apparent in our type 2 muscle fibers and are characterized by significant decreases in fiber size as well as satellite cell contents as we age. The research gap that I've identified is that most studies concerned with satellite cell regulation in aging muscles tend to focus on the effects of resistance exercise, and less is known about the effects of aerobic and interval exercises on satellite cell regulation in aging muscles. The purpose of this study was to conduct a literature review to identify the effects of resistance, aerobic, and interval exercises on satellite cell regulation in aging muscles, and to compare their effectiveness against sarcopenia with focus on underlying mechanisms. My methods began with a literature search using PubMed and Google Scholar databases. I identified 28 studies using keywords satellite cell, aging, resistance exercise, and aerobic exercise. Study inclusion depended on meeting three criteria, including an exercise training model, aging subjects, and analyses of satellite cells before and after exercise. 21 studies met these criteria and were included. Results are displayed here, and due to extensive effects of sarcopenia on type 2 muscle fibers, I focused on increases in satellite cell contents and fiber type transitions in type 2 muscle fibers, and additionally focused on enhanced muscle fiber capillarization and blood flow, and restoration of age-impaired genes in satellite cells. The number of arrows corresponds with how impactful each form of exercise is to each category. In conclusion, studies show that resistance exercise provides more potent stimulus for type 2 muscle fiber satellite cell regulation than aerobic exercise does in aging muscles. However, aerobic exercise is not without its benefits, providing a stimulus that increases angiogenesis and capillary density in muscle fibers. An adaptation that does not share with resistance exercise may be beneficial for satellite cell regulation in aging muscles. Additionally, interval training is not as efficient as resistance exercise in satellite cell regulation in aging muscles, but nevertheless, concurrent exercise training programs using resistance and aerobic exercise may still be effective in rejuvenating type 2 muscle fiber satellite cell pools, as well as enhancing capillary density through angiogenesis. Finally, I would like to thank my faculty mentors, Dr. Yuho Kim and Dr. David Cornell, for their continued support throughout the duration of this project. Thank you for listening.